work really hard at and get good at balancing chemical equations. So like the little activity yesterday and the idea about the law of conservation of mass is that when a chemical reaction occurs, you got to have the same amount of mass of reactants as you have the mass of products. Matter is not created or destroyed in chemical reactions. Instead, it's just rearranged or transformed. But another thing that's true is that the number of atoms of reactants and the number of atoms of the products are identical as well. That like however many carbon atoms there are as a reactant have to be exactly the same as the number of carbon atoms that come out to be as a product. And in our chemical equations, those skeleton equations that we had, let me just erase this. This is like an idea of a skeleton equation where there's two reactants. This is a double replacement reaction. There's like calcium hydroxide and hydrochloric acid, and that makes calcium chloride and some water. That's weird how I just did that. The atoms get rearranged. So in the first case, there's like calciums with hydroxide, but then in the end, calciums with chloride. And as reactants, hydrogens with chlorine, but then in the end, hydrogens with oxygen. Now there's also like hydrogens here and hydrogens here. So there's two different places where there's hydrogens. But the atoms get rearranged. In this reaction though, you see there's only one chlorine. There's just one chlorine atom. But on this side, now there's two chlorine atoms because there's a two afterwards. So it looks like from this reaction that somehow this one chlorine atom magically makes like two chlorine atoms. And that can't happen. Similarly, on this side, this two means that there are not only two hydrogens, there's also two oxygens. But not only are there two hydrogens here, there's also one more right here. So there's like three hydrogens on this side, two over here and one over here. But then there's only one hydrogen. So it's almost like a chlorine has appeared and a hydrogen has disappeared. That doesn't happen. So instead, when chemical reactions happen, atoms have to go together in certain ratios. So let me give you like a for instance. If you're making like a hamburger, you need like two buns and like one piece of meat and then maybe like three little slices of onion or something. There's a proportion and a ratio at which they have to go together to make the whole hamburger. If you're making hamburgers and you're like, oh, I'm making hamburgers. Hamburgers are composed of buns and meat and onion. And every hamburger you make is always one piece of bread and one piece of meat and one onion. That's like an open face hamburger. You know, there's no like bun on top. That's weird. It's not right. It's the same thing with chemical reactions, except although you can be creative when you cook, and you can make things in different ways. You can make a Big Mac and that's got three buns and two pieces of meat, but it's always the same proportions. In chemical reactions, it's far more strict than that. If you're making calcium chloride, this calcium chloride, it has to be one calcium and two chlorines. It can't be three chlorines. It can't be one chlorine. There's a particular ratio of the individual parts. Now, in this example, I can do a process where I balance the equation. And what balancing the equation means is to get the same number of atoms on both sides. And it turns out that on your on this activity, you picked up the Intro to Balancing Equations lab. And if you're remote, I can show you what to do like as soon as we're kind of like done here. In this example, this is not in the lab, but in this example, there's CaOH2 and this hydrochloric acid. I need to put a 2 in front of this compound. And when we were practicing writing equations, a couple times I encourage you to like leave a little space here because there's a number that's going to go there. And we're going to go back and use some of those examples that we used earlier. And then I also need to put a 2 over here. This equation now we say is balanced. And it's balanced because on this side, I've got one calcium. On this side, there's one calcium. On this side over here, because there's a 2 outside the OH, I got 2 oxygens. And over here, the 2 in front makes it so there's 2 oxygens. And then on the left, there's a 2 with a hydrogen, so that's 2 hydrogens here. And then a 2 in front of this is another 2 hydrogens. So there's 2 hydrogens here and 2 hydrogens there. That gives me 4. On this side, 2 times 2 gives me 4 hydrogens. And then because there's a 2 in front of the HCl, means there's two chlorines, and we end up with the two chlorines. So I've got the same number of atoms on both sides. But more importantly, what this balancing process tells you is that to make this reaction work, you need one calcium hydroxide, but for every calcium hydroxide, you got to have two hydrochloric acids. If you try to react like one calcium hydroxide with one hydrochloric acid, the reaction doesn't go, it's not complete. It won't work. You've got to have one of these and two of those. So if you're making like the world's simplest hamburger, which is just a patty of meat and two buns, you don't have the hamburger unless you got the two buns to go with the one piece of meat. It's not one bun and one patty. That's not right. You got to have two buns and one patty. So here, two hydrochloric acids and one calcium hydroxide. So this activity helps you see how that works visually. On the top, there's these are the atoms we're going to over: hydrogen, oxygen, calcium, chlorine, and potassium. And you need a certain number of them. So you got a baggie with M&Ms, and if you didn't pick one up, you got to pick one up. What you need to do is assign a color to an element, and your bag could be different than somebody else's because it's just like the way we counted them out. So I found a bag, and it turns out, in other words, like somewhere in your bag, you've got at least 6 of 2 of the colors, but you only got like 2 of some of them. Like you, in the bag that I found, I can't decide that potassium is going to be yellow because there were only 2, or there were 6 yellows, but only 2 browns. So in this example, if I decided for my M&M bag, I'm going to make yellow hydrogen, make red oxygen, orange is calcium, blue is chlorine, and potassium is brown. In a way, you've got reactants and you've got products, and none of your M&Ms can disappear, and none of your M&Ms can just show up. So you can make a little pile. So if I'm going to try to make this calcium hydroxide, what I want is to have a compound, and I don't have the color orange on this, but it's good enough. I got like, for the calcium, I have like 1 calcium, and that's like orange, because I've decided orange is calcium. I don't know. There, I'll put a little yellow on top of my red. That's orange. That's not so bad. And then oxygen is red. And then my hydrogen is yellow by itself. But there's 2 hydrogens and there's 2 oxygens. So when you see the chemical equation, there's 1 calcium, so that's 1 orange. I got 2 oxygens, and I call those red, and 2 hydrogens, those are yellow. And then the HCl, there are 2 separate individual, they're not molecules, but 2 compounds of HCl. I've got a hydrogen, which is yellow, and then a chlorine, which is blue, but there are 2 of them. So in a way, I've got like one of these calcium hydroxides. You got a little pile with calcium hydroxides, the atoms that make it up. And then I've got 2 piles, because there's 2 HCl's, hydrogen, chlorine, hydrogen, and chlorine. So altogether, you can see that I've got 1 orange one, and then there's 2 red ones, there's 4 yellow, and there's 2 blue. So when you're done, you ought to have the same thing. So whenever you're finished, this calcium chloride, there's only 1 calcium chloride. The calcium's got that orange that came over from the calcium hydroxide. And then 2 chlorines, those are the 2 blue ones. But then there's 2 separate H2Os. And this screen, it doesn't look so good. This one, it looks like better. And each H2O is 2 yellows and 1 red. There we go. So the idea is that the number of M&Ms that correspond to your reactants turn into the same M&Ms, but rearranged in a different way as products. And if you've got some extra M&Ms when you're done, or there were some M&Ms where you started and it wasn't okay, then the reaction's not balanced. People also kind of think about it like as Legos. You know, you can have a bunch of Legos and you can rearrange them in different kinds of ways, but maybe you've got some kind of rule where you're playing with Legos, you got to use the whole set. You can't get rid of or have new ones created. So in this exercise, the equations are already balanced for you. And when the equations are balanced, there are those coefficients in front. So when the coefficient is in front, this value here, like the 2 or this 2, just like you'd have a coefficient in an algebraic equation, like 2x plus y is equal to 4, you call 2 a coefficient in front of a variable. We treat the thing the same way with chemical reactions, where there's this coefficient which tells you how many of this thing. And actually, it's kind of better to think about this 2H2O is sort of like any algebraic equation that would look like 2 times like 2x plus y. And what you do is distribute the 2 into it. So when you distribute the 2 into this equation, like 2 times 4 is 4. So altogether there's 4x's plus 2 y's. And that's what happened here. There's 2 H2O's, so that there are two water molecules, 2 molecules each with hydrogen. 2 times 2 gives you 4 hydrogens. That's why there's 4 yellow dots. And 2 times 1 oxygen gives you 2 oxygens. So every chemist all over the world, no matter what country, no matter what language, no matter who's doing it, we all write chemical equations the same way. We all use coefficients and subscripts in the same way to illustrate numbers of atoms. This equation, written CaOH2 plus 2HCl, yields CaCl2 plus 2H2O. Every chemist on the entire planet understands what that means. They may say it in a different language. They may call the elements something different, but it's absolutely completely universal, and this is totally the way that it's done. This isn't some kind of like Mr. Flint's crazy in Williamsport kind of way. That's the way it goes. The whole M&Ms in a bag, people do that a little bit differently. That's the way to think about it. Anyway, so this activity walks you through building the different kinds of reactions. This example that I did is not on the paper, but it uses the same elements. There's a reaction with, like number 3 is calcium oxide and hydrochloric acid. Number 4 is potassium chlorate, makes potassium chloride and oxygen as a decomposition reaction. There's a synthesis reaction in number 5. Hydrogen and oxygen make water. Number 6 is a double replacement, much like this one, which is actually the most complicated. So anyway, that's the role of coefficients in reactions. So if you didn't pick up a pack of colored pencils, someone beside you or near you ought to have one, and you might have to like change up the colors. You know what I'm saying? Like your color is different than another color. But if you don't want to use a colored pencil, that's okay. You can just like, label colors for dots on the paper or something like that. I guess there's brown in there. Is there brown in that pack? It's like a 12 pack, right? 24. Brownish. Good enough. All right, cool. I never got the 64 pack when I was a kid. The crayons? 64 pack's got the sharpener. My mom was always like, 36 is enough for you. Like, but everybody else has a 64 pack. They're like, we don't have that kind of money. And then later on in life, I found out like the 64 pack of crayons is like $3. And it's not even expensive. Like when you're like 6, $3 is, you don't know what that means or how much that is. My parents were good enough to convince me that it was exorbitant. They were probably right, because you can like mix them, right? Sort of. All right, that's cool. Okay, so if you're a remote student, so you can work on that. If you're here, let me show you what to do. Let me get new share, Safari. If you want to work at a lab table, that's cool, because the pencils and the M&Ms don't roll off the desk. Okay, so the intro to balancing equations, if you're remote, when you click on that, it'll open up a Word document. Let me get it open here. Okay, so if you happen to have M&Ms or Skittles or some other colored thing, that's okay. But if you don't, and you happen to have like some color, just colored pencils or crayons or something like that, just like how I illustrated in the example, drawing like dots in boxes with different colors. If you just have 5 different colored markers, pens, crayons, or something, just assign one color to each of the individual things. And then if you're doing like water, 2H2O means there's 2 water molecules. Build 2 water molecules. So if you have the objects, that's okay, but you can also just draw as dots. So if you're going to represent hydrogen, hold on a second. That didn't share like I needed to. I'm so sorry about that. All right, so whenever you open the intro to balancing equations, all right, I'll say this again. If you have colored candies, M&M Skittles, or beads, or colored paper clips, that's all right. But if you don't, totally okay. But you ought to have some crayons or colored pencils or something else. You can just assign a color to each of these different elements. You can be like, oh, hydrogen, make it like red, oxygen, orange, calcium, blue, chlorine, green, potassium, purple. It doesn't really make any difference. 2H2Os means there's 2 water molecules. So if you're going to build 2 water molecules, you can draw like little circles to represent them. So if you called hydrogen red and then oxygen like orange, your water molecule will be like 2 red circles and an orange circle. But because it's 2H2O, there's 2 molecules of hydrogen or 2 molecules of water. So you got like red with 2 circles here, and maybe a red 2 circles over here, and then there's an orange for the 1 oxygen and an orange for the 1 oxygen. So 2H2O altogether, you would have 4 hydrogens, because since each water molecule contains 2 hydrogens and you have 2 of them, it's like 2 times 2 gives you 4. So there ought to be 4 hydrogens. And then because there's 2 molecules with water, 2 molecules of water, each with 1 oxygen, 2 times 1 is just 2. So if you have like different colored candies or beads or something where you can have a consistent color for each of the different atoms, and those are the numbers of them that you need. So you would need 6 hydrogens. Not in every case do you need 6 of whichever one you call hydrogen, but you can just sketch it or draw like circles. So I'll show you what I mean by that here. Let me share a different screen. So if you're going to call, I'm going to wait for my share menu to come up. So for instance, that one where it's like 2H2O, I'll just draw it over here. So for 2H2O, if I've called hydrogen yellow, then I've got 2 water molecules. Well, water each contains 2 hydrogens. So I've got like, there's one of my water molecules with its 2 hydrogens. There's my other water molecule with its 2 hydrogens. And then if I called oxygen red, then I've got a red one here and a red one here. So this little pile of circles represents 1 water molecule, each with 2 hydrogens and an oxygen. And this represents another water molecule with 2 hydrogens and oxygen. So altogether, you have 4 yellows. So that's 4 hydrogen atoms. And then you have 2 reds. So that's 2 oxygen atoms. And as you work your way through, you'll see that just like in the example I did here, if you can just draw them as colored dots, the number of colored dots that you have for reactants, that's all of these, should be the same as the number of colored dots you have for products. And even if you don't have colored pencils, you can at least make a list of what you've got. So for instance, here you've got 1 calcium, 2 oxygens, 2 hydrogens, and then here, because there's a 2 in front, another 2 hydrogens and 2 chlorines. So altogether, there are 4 hydrogens, 1 calcium, 2 oxygen, 4 hydrogens, and 2 chlorines. Whenever you're done, you should have the same thing. So there's 1 calcium, 2 chlorines, and then because it's 2 times 2, you'd have 4 hydrogens and 2 oxygens. So altogether, 1 calcium and 1 calcium, 2 oxygens, 2 oxygens, 4 hydrogens, 4 hydrogens, 2 chlorines. Oh, this is, yeah, and 2 chlorines. That's a way to like kind of reconcile the number of atoms on each side of the reaction. So I mean, you can do it a couple different ways. You can just write in here what you get. You don't have to include the colors, but I mean, if you have a printer and you want to print this out and then draw the colored things on there, that's okay too. Whatever you want to do, just save it and then submit it, and that should be good. So you don't have to stay in the room. If you just want to work on that, that's cool. Okay. Yep. Let's see. If you have questions, you can put it in the chat or you can turn on your mic. Let's see. Desktop 2. Yeah, or you can, if you want to draw another paper and turn it in, that's okay too. Look at the chat. Hey.
Just for the right side, this thing.
Yeah, like the reactants are these here,
So,
and then those are the products. So
it was, oh, because it was both.
yeah, does that make sense?
Yeah.
Oh yeah. I don't know. Oh, yeah. Yeah. Oh, no, they do.
Shouldn't. I mean, especially if you had them on a lab table, you know what I mean? Like, you could, but
I know some people.
if they did, they did. I mean, if you, they were clean and sanitized, like we did it with like gloves and stuff.
Yeah.
If you left it on your paper, it'd be okay. But
Yeah.
lab table, I don't know.
I left it on my brown. It doesn't do a lot. You know, because the main thing that happens. I asked her for. I'm glad my I'm already. Yeah, that might be. No way. I'm just over a 7. I have a 59. And now I revisit that at those that I can get. I did my final year 8 and I'm just trying to get yeah, my company is that I'm 20. Oh yeah, the presentation thing. I lost it. Well, I don't know what that yeah, when I was doing that presentation, you did not on that. They hit it hard and he said, hey, question mark that.
stack up on the desks. Up on the desk.
I noticed that. I said I'm gonna upload an assignment. She said I'm not gonna accept the assignment, but I said I'm gonna upload it again for the second time. She said, okay, well, that's also the same time that I told her. I had like a 30-minute meeting with her. So you're at a.